Hello, and welcome back to another Ivy Math Speedrun with me, Vince. So in this video, we're going to be going over more, rules for differentiation, specifically focusing on the product rule. So let's jump right in. So we've already covered that if you have a function that's actually just two functions added together, the same goes for the derivative. The derivative of the original function is the derivative of the two functions added together. But it's a bit different for multiplication. So if we have if we have an original function that's composed of two functions being multiplied together, the story is a bit different. I can't write a v2. Because the derivative of the original function is then equal to ux times v prime. So one of the original subfunctions times the derivative of the other, plus, well, the other way around as well. So this is an important rule to remember, and if another way to write this, which I normally prefer, is if y is equal to uv, dy over dx is equal to u dv over dx plus v du over dx. So this is called the product rule, and it will be very important. Yes. Okay. So let's jump into some functions right now. So we need to differentiate these following functions with respect to x. I'll do the odd ones. So the first one is y is equal to 2x minus 3 times x plus 3 cubed. So we can call, first we're going to have to chain rule this, but we can say u is equal to 2x minus 3, v is equal to x plus 3 cubed, and w is equal to x plus 3. So v is therefore equal to w cubed. So first we want to find dv over dx, and that will be equal to 3 times x plus 3 squared. Using the chain rule, if you don't know what chain rule is, watch my previous video. But, okay, so we have dv over dx now, and so now we need to find du over dx. Du over dx. And that will be equal to, let's look at what u is, 2x minus 3, so this is simply 2. So the original equation, the derivative of the original equation, so dy over dx, will be equal to u dv over dx plus v times du over dx. So this is equal to u times d. So u is 2x minus 3 times x plus 3 squared. So 3 times 2x minus 3 times x plus 3 squared plus v times du over dx, which is equal to x plus 3 cubed times 2, so 2 times x plus 3 cubed. So this is our final answer. And again, you could simplify it, but I don't think that's the focus right now. So we're going to ignore any simplification. Okay, next question, which is y is equal to x minus 1 over x plus 1. Okay, I mean, sure. And we need to differentiate the following function with respect to x. How would we go about it? Why would we need to use product rule for this? It doesn't make sense. This is silly. Fine. Okay, so technically we can express this as x minus 1 times x plus 1 to the negative 1. And so we have u is equal to x minus 1, v is equal to x plus 1. So let's get the derivatives. Du over dx is equal to 1. dv over dx is equal to negative x plus 1 to the negative 2. And so dy over dx will be equal to u times v prime. So this is negative x minus 1 times x plus 1 to the negative 2 times x plus, like, plus x plus 1, really. So yeah, this should be the correct answer. Yeah. Okay. So on to the next question. Hold on, actually, I think I've skipped something. This should be x plus 1 to the minus 1. So this should be simply x plus 1 to the minus 1 over there. Okay, now that's corrected. Let us move on to the next question. And the next question is asking for, we have y is equal to 1 over x cubed minus 2x squared plus 3x plus 1, and find the derivative of this. So, yeah, this one is going to be a bit harder, you know. Well, I mean, I guess we have to go like, this is equal to 1 times x cubed minus 2x squared plus 3x minus 1, and then simply, plus 1, and then simply chain rule it. So this would be equal to, say, u is equal to 1, du over dx is equal to 0, and then v is equal to x cubed minus 2x squared plus 3x plus 1 to the minus 1, and then dv over dx is equal to 3x squared, negative 3x squared, minus 4x plus 3 times all of that again. So this would be times x cubed minus 2x squared plus 3x plus 1. And so, I mean, we have the only, because since we were multiplying this by 0 over here, this part won't matter. So dy over dx should simply be equal to 3x squared minus 4x minus plus 3 divided by x cubed minus 2x squared plus 3x plus 1 squared, all squared. Yeah. So that should be it. So we can move on to the next question. And the next question is asking us, oh, sorry, this should be negative, because I forgot the minus sign. So negative 3x squared plus 4x minus 3 all over this. And so we can move on to the next question. The next question is y is equal to 2x minus 1 cubed over 4 minus x squared, where of course x is not equal to negative 4. So we have u as 2x minus 1 cubed, and so du over dx is equal to 6 times 2x minus 1 squared. V is equal to 4 minus x squared, and then dv over dx is equal to minus 2 times 4 minus x. So this new thing should be equal to dy over dx And that should be equal to 6 times 4 minus x squared times 2x minus 1 squared minus 2 times 4 minus x times 2x minus 1 cubed. So yeah, that's what this should be equal to. Okay, and then on to the final question. And so the final question is, we need to find the equation of the tangent and normal to the curve of y is equal to x squared plus 1 over x squared minus 3 when x is not equal to plus or minus the square root of 3 at 1, 0. So we need to find a tangent and normal at 1, 0 on this curve. So first let's get the derivative. U is equal to x squared plus 1. Du over dx is equal to 2x. And then we have here v is equal to x squared minus 3. dv over dx is equal to 2x again. X squared plus 3 to the minus 1, of course. And so this should be times x squared minus 3 to the minus 1. Minus 2, sorry. Actually, hold on. This would be negative 4x, sorry. So we would have dy over dx is equal to 2x times x squared minus 3 to the negative 1 minus 4x times x squared plus 1 times x squared minus 3 to the negative 2. So we're looking for the tangent and normal at the point 1, 0, so you can simply substitute 1 as x, so this is equal to 2 times 1 minus 3, negative 2 to the negative 1, minus 4 times 1 plus 1 is 2, times 1 minus 3 is negative 2 to the negative 2, so this is negative 1/4. Oh, sorry, this is just 1/4, sorry. So this would all be equal to negative 2 to the negative 1 is equal to negative 1/2. So this is equal to negative 1 minus 2, really. So this is equal to negative 3. So the gradient of the tangent will be equal to negative 3. And is this correct? Wait. Negative 4x. No, this should only be negative 2x. Oh. So we really only have minus 2x here. So this is minus 2, minus 2. And so yeah, oopsies, I made a little mistake. So this should be minus 1, which is equal to minus 2. So the gradient at this point of the tangent is equal to minus 2. So if we go back to the original equation, the gradient will be equal to y is equal to negative 2x plus c, and the normal will be equal to y is equal to 1/2 x plus c at this point 1, 0. So we got to substitute. Oh wait, we already have the coordinates 1, 0. So we can simply substitute this here. 0 is equal to negative 2 times 1 plus c. So c equals 2. So y equals negative 2x plus 2. And then similarly for this other point, we have y equals 1/2 x plus c. So y equals 0 equals 1/2 x plus c. So c equals negative 1/2. Sorry, 1/2 times 1. So yeah, c equals negative 1/2. So The tangent is negative 2x plus 2, and the normal is 1 half x minus 1 half. So yeah, that's all for the speedrun. I hope you enjoyed it, and I hope you now know some more about product rule and you can differentiate some more functions. See you in the next one.